The second question asked, which way will the 50 kilogram box move? Up the plane or down the plane? So this is the 50 kilogram box. They're asking if it's moved up or if it's moved down. Or will it even move at all? Show why or why not. So in order to answer this question, basically we need to answer about the acceleration of the box. And here this is the first box, the box 1, this one, just like label them as 1. Okay, and actually they ask him for this, the acceleration. So in order to find the acceleration of the box, usually we will start with the Newton's second law, because with the Newton's second law we can have like on the F nets that acting on the mass 1 equals to mass 1 times with A1. So if we can find all the forces here, the value, then we can find the acceleration. So let's see if we have everything. Here we know that we have the weight, right? We have the mass. Yes, we can do this one. The tension, well, we don't have any information about the tension, right? So that's why just up to this point we get stuck if we got into this approach. So it seems that this approach doesn't work. So instead of like looking at mass 1 as itself, we can see the whole thing here, the system of mass 1 including the rope and this mass 2, for example, mass 2, let's label them as mass 2 for this one. So we can include everything here in one system, and then we treat them. Maybe we can figure out the acceleration. So let's see if we can do it. So we can see that this mass A2, sorry, this one should be A2. A2, it should be the same like the acceleration of the M1, and also like the same with the system, include both of them. And now we need to apply the Newton's second law. External net force equals to all the mass in the system times with the acceleration. And now this is the external, okay? So let's see. We have the free body diagrams here. But we only need to include the external force in here. So we can see that the tension, are they external? No, right? Because this one is is exerted by the mass 2 on the mass 1 is internal, and this one is exerted by the mass 1 on the mass 2, so it's also internal. Okay, they are on internal. So if it's internal, it's not external, so we don't include them in this list here. So listed here just the weight 1, the normal force on weight 1 here, and 1, and the weight of the mass 2, weight 2. So there's just 3 external forces here. Because this one is frictionless, so we don't have a friction force here. If there's some friction, then we should also include a friction here. So there's just like 3 forces that act as the external. And then from here we can see now the problems kind of like more complicated a little bit compared to other problems, because here we can see that if the weight go this way, and then this one go this way, like there's no forces that in the same direction, so it make the addition, the force addition in here, because they are on vector. So we had to apply the rules of vector additions in here. It's not as simple like other problems. So how can we do it? Well, there's always a solution out. So now people do it by experience, that we can analyze this weight 1 into 2 components, x and y. So what are the components? So the tip Okay, this is a tip. Whenever you need to analyze a force vector, you should analyze them in the motion direction. Okay, you should analyze them in the motion direction. Why? Just think about it. Because we want to see how forces influence the motion of the objects, right? So we should choose the motion direction as one of them. Make sense, right? And then we choose the other direction to be perpendicular to the motion direction. So then in that way we can have like the two axes, the two components perpendicular to each other, and it will make the math much easier. So in this case, what I'm having right now is that you can see here, this is the weight, and then I choose this one. This X look like this because that will be along the ram, because we could expect that if there's some motion it should be like along the plane, right? So this is the motion direction. Okay, and then the other axis should be vertical, sorry, I mean perpendicular to this one. Okay, perpendicular to this one. So that's why I choose X like this and then Y like this, and then by applying the vector addition. So if you want to review about vector addition, there will be another video about it. And now here, just come back to this one, we see that we can analyze W1 into two components. One on the motion direction is W1x, and one in the other direction that perpendicular to this one, that will be the W1y. So basically we just analyze the W1 into two components. Why we need to do so? Because if once we got this one, actually it cancel out with the normal force. It makes sense, right? Yeah, because like the box just move in this direction, it doesn't like jump while it's moving, right? So there's no acceleration in this way, and that means that all the forces should be like balanced with each other on this direction. That's why those cancel each other. So what left is just this one, and then the weight too, and then the whole thing here. So then it can make the math much more easier. Next, we will need to identify the magnitude of this one and this one. So how can we do it? So this is like also from vector addition rule, and here you can see W1 here, it this way, right? And this is the let me highlight it though. Let me highlight it. Now we focus on this one. Now we focus on this one. This one. And this is the component. So do you recognize that it's just like a right triangle? And then with this one we can apply some rules, right? And take advantage of the cosine, the sine, and we can calculate the magnitude of the W1x from the W1. Okay, so how can we identify the angle? This is a tip. Okay, the best way is that I draw this one as big as possible. So whenever you draw the weights really huge and big, you can see that it's always perpendicular to the horizontal like this, right? Yeah, it's always perpendicular to the horizontal like this. So actually it just create another triangle. Do you see it? Right? And do you realize that those triangles are congruent to each other? See? Even this one as well. Right? They are congruent to each other. So that's why we can easily see that this angle to be 30 degrees, right? Or if you have a look at this way, if this is 30, then this one should be the 60. So then if we got like this one is perpendicular here, then this one also should be 30. You see? So there's many ways to identify the angle. The key is that you know that you can draw the direction of the weight and its component. That's the key. So whenever you do these problems, draw them out. Okay? short amount. Okay, so back to this point, we are here at calculating the magnitude of W1x. So then we got, this is a right triangle, so the Wx here is actually opposite to the angle. That's why it multiplies with the side of the angle. And then we just need to plug in the values. And then we can find that the magnitude is this much, 245 Newton. Okay, so now we're done with this one. The last step is to calculate the magnitude of W2. And in order to calculate the magnitude of W2 is quite simple, right? Just mg, mg here. And then finally we got this one, this much. So now, how can we know if it's go this way or if go this way? Well, if the force go this way is stronger compared to the force that pulling it down in this way, like this one have a tendency to pull it down, right? And the weight 2 will move it this way. Then you can see this one is greater. That's why this one should go up, okay, right? It should move up. So that's the conclusion. We got this one go up, and then the F net will be in the same direction with the F net, and F net is this way. So that's why A is this way, is move off the ramp along with the object 2, box 2, move down. That is okay.